Good afternoon. Thanks, everybody. Just in case there are a few people in here that came in and weren't in the last panel, I'm Bonnie Estes. I'm the Vice President of Innovation at the International Fresh Produce Association, and we're an association that works with our members all the way from crop inputs like breeding and crop protection products through growing, through transportation, and through retail. And so we work through the whole produce supply chain globally. So I feel really fortunate to get to touch on all the different points and bringing you the best produce. We have a great panel today, and we are talking about robotics, which is an exciting topic and fits right into what's going on at CES. So many exciting, I'm sure you guys all walked the floor and looked at all the amazing robots and just how good they're getting at picking up things and really some of the small motor skills that I see out there. So it's really exciting. And now we're trying to look at, how is this used on the farm, and how are we using robotics to really improve the way that we grow food. And in our pre-call, I think we all realized we have a little bit of an ulterior motive here in that we want to bring more talent into the industry. So those of you that are out there that are interested in robotics, you should be in agriculture. It's a really cool place to be. So hopefully after this panel, you'll get a feeling and you can talk to any one of these three about what the potential job market is. So I will now move into letting the panel introduce themselves, but we have a real treat for you today in that we really think that when we're talking about robotics, the best thing to do is to be able to see something in action. And so each of the panelists has brought a video that they're going to talk over and kind of explain to you about what's going on and why this is important and why it's relevant. So what I'll do is I'll have, Brett, we'll start with you, have you introduce yourself, a little bit about your small company that has a small booth, and then we'll signal for the video to start, and then you can walk people through the video.
All right, sounds good. My name is Brett McMickle. I'm the Chief Technology Officer for Kubota North America. And yes, we do have a booth just downstairs, so I hope you come down and see it, just off door number W3, booth 5700, so come and see. You want to go into the video? Or?
Yeah.
Okay.
So you're going to have to turn and look that way.
All right, so at Kubota in the booth, this year we really expanded our exhibit to show a broader portfolio of our solutions. And we're highlighting actually the application to the growers and to our customers rather than highlighting the technology itself. So you saw at the very first the AgroConcept 2.0. That's an EV autonomous utility tractor. We have a hyperspectral imager on the KATR. And you'll see the KATR show up in a number of different scenes here, a very versatile four-wheeled platform. And it's also the CES Innovation Award winner. So you can see a live demonstration of that in the booth. Here we have a sprayer. So that's a smart autonomous sprayer. Not only is it autonomous, but it also has sensors on it that allows it to check the density of the foliage and adjust how much spray based on the density. So it sprays with precision. And another shot of the KATR. This is mobile transport. And then all of the autonomy stack is similar across all of the platforms. And so here at the smart autonomous mower, and we're showing here the collaborative technology. So you can use these devices, or these robots actually speak to each other and can be tasked together. So they're aware of each other, and they actually work together to provide a solution. So imagine KTR walking through, like, say, a vineyard, scanning, providing that information back to AI. AI creates a recommendation that might queue up either the utility tractor or the autonomous sprayer. So we're really trying to connect the assessment, the analysis, and the action all together to complete a full work cycle. And I mean, Kubota is really about enjoyment of life. So we do have scenes on showing that how we're contributing to enjoyment of life. It's not all work. Agriculture is a nice lifestyle as well, and so we're helping people out. Thank you.
So are these, this is out in the marketplace, people are buying them. Did you just introduce a lot of
So
These, or is
it's
it
a
new?
mix. Some of them, like the AgriConcept 2.0, is a concept. For those of you that saw our exhibit last year, we had an electric vehicle concept, and we got a lot of feedback, both positive, and then we got some, hey, you know what? There's some things that we'd like different. And so this year we built on that. One of the primary, I'd say, complaints with the autonomous tractor that we introduced was, I like to drive my tractor, you're taking that away from me. Or there are a lot of tasks on the farm that are just kind of ad hoc. I drive it from field to field. I've got a lot of a lot of unplanned activity, so I need a utility tractor I can drive. So this year, the AgriConcept 2.0 provides that choice. So it's fully autonomous when you want it to, but it also allows for manual control. So that one's a concept. The KATR, that's commercial. We released that in the Japanese market first. Excavator is commercial. The sprayer is still in a prototype phase, so it's a bit of a mix.
Yeah, great. Thanks. That's a really good picture. Scott is the VP of Global R&D from Driscoll's, and so we thought it'd be interesting to have, along with equipment manufacturers, to also have an actual producer and someone who's using this technology out in the field. So Scott, if you could introduce yourself, and I'm sure most people know Driscoll's, but and then we'll show your video.
Okay, thank you, Vonnie. Scott Komar, Senior Vice President, Global R&D of Driscoll's. We are the world's largest berry company. All we do is fresh berries, strawberries, blueberries, blackberries, raspberries. And on each continent, we have a business model where we are producing and growing these berries as close as we can to our consumers. It's in the production side, obviously, where we are most interested in robotics. And in particular, the way our model works is we have over 1,000 independent growers around the world. These are essentially their own business that they're managing. So we're going to see some examples here in a second of how they're starting to adopt to the robotics and on their farms. So here's an example from Southern California, a company called Trick Robotics. This machine is using ultraviolet light to disrupt a fungus, powdery mildew, that's very common in all kinds of plants, including, in this case, we can see the strawberries. If you've ever been out to a strawberry farm, you can see it's very large scale, and so we like that technology. Here, our growers in Australia are using a product called Burrow. These devices, as kind of the name implies, just help shuttle materials back and forth from the one field office out to the ranch and back. Here's a product, a Chinese company, XAG, that's applying spray applications to, in this case, these are raspberry plants, and autonomous tractor that's used down the rows here. And so we like this because it besides it being, without labor, it's also very efficient materials. Here's product that's being used in the UK, NIO. Again, it's ultraviolet light, and in this case you can see, because labor is so expensive in this region, everything's off the ground. And so this device roams through. These are very early stage strawberries we're looking at. And then here in our nursery plant, these are actually very juvenile little raspberry plants. And we produce several million of these each year. And so this robotic in our nursery site is taking these juvenile plants from the lab and is placing them in these little grow cells that you can see over and over and over again. And so this company, TTA, we like a lot because it's been a very reliable example of robotic. But as you can see in the video, it relies on a fixed location, unlike everything else that we were looking at that's out in the farm. It's really got to be able to navigate that environment.
A lot of these farms they're solely owned. You don't own them. How much influence do you have on whether they adopt technology, or what's your interface with the adoption on the farms?
As I mentioned, just about everybody in my group, it really helps if you can polish your persuasion and influencing skills, because again, we say the word independent, and they are independent. They're running their own business. They are dedicated to the Driscoll's growing system, so that's all they're doing. If they're growing Driscoll's berries, that's it. But they're making their own decision for how they feel is best to be running their farm. And accordingly, you can see we have quite a range of different things being trialed. And it's interesting to see, and maybe we'll talk about this later, just how it's emerging differently on each continent, because there's some key differences we're starting to see that just reflect the economic realities in different continents, labor availability, and so forth.
Great, thanks. Gaurav, you're another small company that you work for, John Deere, that has another small booth down on the floor. So everybody should go visit them. I got a cap.
We have caps too.
Nobody offered me a cap in your booth. I'll have to go get one. Excellent. So why don't you introduce yourself and maybe touch a little bit about how you came to John Deere. I think that's kind of an interesting story to understand, what how Deere is looking at the market, and then also do that, and then we'll go through the video.
Yeah, no, thanks, Vani. I'm super excited to be on this panel with Brad and Scott. So my name is Gaurav Bansal. In my current role, I'm VP of Engineering at Blue River, which is a fully owned subsidiary of John Deere. And my responsibility is to lead engineering products in autonomy in agriculture, construction, and turf. And before going to Blue River, when Vani and I were chatting earlier in a call, so I graduated like roughly 15 years ago. And in my career, I've only worked on autonomy. I did it in cars first for Mercedes-Benz and Toyota. Then I worked in aviation at Airbus, where I was part of this project where we landed the world's first airplane, commercial airplane, A320, in Toulouse, France. But then that brought me to my journey to John Deere. And what really drove me about Deere is like we're doing a real purpose tech. So in Deere, we really believe in talking to the customers, identifying what is their biggest pain point and how can we make a difference. So in last many years, when we have been interacting with our customers, one of the biggest pain points that they have been highlighting to us is the labor challenge. The average age of a farmer in the US today is 58 years old. Farmers typically in US, they're looking overall 2.4 million farm workers every day. So we are like, this is a problem that we really want to solve and make a difference, in our customers' lives. So if you'll roll the video, what we have done in this CES is we have unveiled our Generation 2 autonomy kit. So this is a solution that uses 16 cameras and 2 computers that have NVIDIA Orin chip that we use. This is a solution that's in market today. We have dozens of paid customers that are using it for tillage in corn and soy in Midwest today. And another kind of really, so this is running in a real customer field with a large, big green tractor and pulling a tool. And another important part that we have highlighted in this CS is with this hardware kit, with cameras, computers, and the GNSS capability, we would be able to make tractor autonomous also for jobs like planting and grain cart. These are the 3 important jobs that the tractor does. And ultimately what it does is it allows farmers to not be stuck in the cab. And then our farmers, when we talk to them, like they make like hundreds of decisions every day. So that gives them the time back and allow them to focus on other important parts of their operation. The last thing I would hit there is, so Deere is obviously like, we are one of the biggest farming equipment company, but we do more than farming. We also have equipment in construction and landscaping. So what we have also unveiled in this CES is that using this very similar tech stack, we are also building autonomy solution for a autonomous dump truck in a quarry, for an orchard tractor for canopies, and then autonomous lawnmower in landscapes. Most of these solutions we're already testing with real customers and planning to make it available, in the near future widely.
Great, thank you. Thanks to all of you for bringing those videos. I think that really helps drive the conversation. So in addition to what we've talked about and what you brought up, if we step back a step and then if I'll ask all of you to reflect overall, where do you think we are in automation and robotics in agriculture? And what technologies are currently making the biggest impact? Brett, we can start with you.
I mean, I think we're really close to deploying full autonomy for certain applications. I mean, I think it's going to be a while before we can fully automate the entire farm. I think that's a bit of a stretch, but there are a lot of tasks, as mentioned, on tillage and planting, but also in the orchard, spraying. You saw Driscoll and the autonomous sprayer Kubota is offering. So I think we're there. We're out in the field. We're testing things with customers. We're there. It's really about and the demand's there. I mean, you're hearing this on the labor side, and there's a couple of ways to look at the labor as well. I mean, just kind of taking a step back is it's not just access to people, but also access to skilled people. So you're going to see like augmented automation, so maybe not full autonomy, but the robots are helping out maybe less skilled labor or just helping the farmer out with some of the tasks. So I think we're pretty close to deploying this for certain tasks.
I'm seeing that a lot. I mean, I'm exposed to more in specialty crops, but the augmented labor in row crops, how is that being used?
If you could jump
as
on,
far as either go ahead and then I'll ask him. No. Brett, go ahead.
Oh, on the row.
Yeah,
I mean,
row crops, yeah.
So I mean, we're more focused on the specialty crop rather than going in onto corn and soy. That's more where John Deere is. On the specialty crop, it's really around spraying. I mean, weeding is another issue that is becoming a bigger problem, especially as you start getting resistance with, to pesticides and herbicides. And so we're having to use, robotics and artificial intelligence in order to tackle weeding as well. So weeding, just overall maintenance, pruning, and spraying are examples of where the automation is being used.
Great. How about you? What are you seeing overall?
Yeah, so the way I would answer that is, so we see we want to build tools that enables farmers to do more with less, and autonomy has an immense potential of how the farming operation would be done, but we have to do it by taking customers' needs in account, and that is what we're trying to do at Deere. By we are providing these tools that seamlessly integrate with their ecosystem today, so they're able to. It's faster for them to be able to adopt these technologies. Other place that we see is also around the precision technologies. We see future to be highly autonomous and automated. So the capability, these machines would allow our customers to be able to tend to a square foot. So this would continue to enable them to take care of their crop at plant by plant level, and that would ultimately drive more sustainable, efficient operations, and then unlock new opportunities. They'll be able to grow in a more sustainable and a more profitable manner.
Scott, what do you see overall? Where do you think we are in automation, robotics, actually on the field level?
We are probably still early stage, at least in our world, and these are rough numbers, but if I were to characterize how we see these farms globally, I would say probably 70% are still not using automation, robotics, and so forth. Of the 30% that are, I echo what Brett's saying. There's a 20% group that's sort of got this harvest assist or mechanical assist, and one example would be harvesting blueberries, where you've got a device that's more, it's not fully autonomous, but it assists workers. They've got 3 on each side of this machine. They can go down the rows, tickle the blueberry plants, get the fruit, and so forth. That is quite successful of an example. So they're getting productivity gains 25-30%, which is amazing. And then there's maybe 10%, that might even be a little generous in terms of ones that are really all in and doing full automation. And the commonality that I see with that is these are the markets where the labor is pegged at the very, very top. So that would be California, England, and Australia, those 3 sites. And it, because their backs are to the wall. You know, they're not going to get bailed out with more labor or less expensive labor, so they have to do this. So it's really driving that adoption. And interesting, because of the counter-seasonal nature between England and Australia, we have growers that they're learning from each other. So, you know, right now it's summer in Australia, so they're in their peak season right now in Tasmania. And so they're learning. Then those learnings they share with their counterparts up in England. They run the same thing then in summer in their season. They go back and forth. So it's kind of fun because they're you know, harnessing the learnings and getting out a little bit further, I would say, than the California group.
Wow, that's fascinating. So how does that conversation happen? I mean, do you facilitate that, or do they know each other? Or?
In one case, there's a shared investment that the two have made, so that's quite unusual. But in most cases, we're sort of the matchmaker, and we're bringing them together, saying, hey, you know, you should contact this grower here because they're doing something similar to what you're doing, and so forth.
You don't
However,
have a WhatsApp group?
Pardon me?
You don't have a WhatsApp group?
We do, and which I can't even keep up with because the pictures and the comments fly around in 5 different languages, and it just goes crazy. So there's a lot of sharing. But the challenge that we have with this, you know, group of independent growers is that as you can kind of see from the video, everybody's trying a little something different. So that idea sharing is, as I think about it, I don't think there's an example where it's actually the same ag tech company that they're using on those 2 continents. Okay,
for the solution, for the equipment?
So you've got with powdery mill, they're like, yeah, we got this solution here in the UK and it's working great. Well, that company is only in the UK. And so when we ask them, like, hey, when are you going to Australia? They're like, no, we're not going to Australia. You know, we're just here in the UK. And then alternatively in Australia, they're kind of a local group. So that's a challenge. I need to hang out with these 2 guys more often because they have
global reach more than some of the
others.
Yeah.
Exactly. So we're going to have some challenges scaling with the way these things are evolving, and maybe we'll get to it later. But China's a whole other topic. You know, that just seems like a really closed environment, and so companies in China are all about China, and if they're outside China, they don't want to go in China, and so there's kind of another ring fence that we're dealing with that's going to be a challenge in the years ahead.
Well, let's talk a little bit about the geographic differences. I mean, Gaurav, how do you work with different? I mean, I know a little bit about Deere's working in Brazil and places like that, but how do you think about these new technologies and going to different geographies?
Yeah, so that's a great question. You know, so today we have even starting like geographies within US. So the way we have built our autonomy stack, so it's one software, one machine learning models that work in Iowa and Texas and Louisiana. Like we don't use a different stack just because we are in a different geography. By the way, same applies for the time of the day. The system works 24 hours of the day, but it's the same software that works throughout the day.
And is that all with corn, or is that corn and soy, or what crops?
So we've started with corn and soy.
Okay.
And so today what we have, it's available for customers in Midwest in these 2 crops. We do as the approach that we always take, we're talking to the growers even beyond US, and in Brazil we definitely hear similar stories around labor challenges that are there. And in future we do wanna be able to have this capability and these tools available to growers in Brazil and other parts of the world. Like in Western Europe is also pretty interesting. They would have similar labor challenges, that we hear from the growers in Midwest, and eventually we do want to be able to, in future, have that capability available to them.
How about you, Brett?
Yeah, I mean, it's really around staying close to the customers and understanding their needs. And so the vehicles and the solutions that we offer, for instance, in our Asian market, like we have autonomous rice transplanters and smaller harvesters. It's really understanding what the customer needs are, providing that technology to them, and then iterating on it and getting, making sure that we're solving their problems. But the challenges are different. I mean, Scott mentioned that. I mean, there's certain areas where it's more about labor, other areas it's transportation, and so it's really understanding geographically what problem that you need to solve, and then working with the customer to solve it. In areas where labor is predominant, it's how do we get this more automated? Other areas, it's more about access to skilled labor, then how do we create augmented automation to upskill? And then other areas, it's, particular tasks may be dangerous or maybe even regulated, and so we'll have to provide a solution for that. So it's really understanding the customer's needs in these different areas and providing the right solution. But also developing it on a tech stack that allows you to transfer that knowledge quickly. And so what you saw in our video and in the exhibit is the underlying technology we can transfer, and we've demonstrated, okay, we can take it from a lawnmower to a sprayer to a utility tractor. Now it's about working with the customer and dialing in what that application is.
And so how many countries are you actually in? If someone was in a country and wanted to buy from you, is it set up logistically that can happen?
We're a global company, so if you want a Kubota tractor, we're set up to service that need. We'll take orders. I mean, Kubota is a 135-year-old company, and so we've been around a long time. It started, it's headquartered in Japan, so we've got a really strong presence in Asia. North America is one of our biggest markets, and so we've have over a 50-year history here as well, building tractors. But we've got a global reach, and that diversity, if you look at our equipment, you can see a wide diversity based on the geographic needs. I mean, sugarcane, the way that they grow and harvest sugarcane in Thailand is different from Brazil, from Australia, and so you've got to fit into the way that they operate and make sure that it works for the customer.
So one of the things that I hear a lot when I'm out in the field, just talking to people who are either trying to develop technology or try to use the technology in the field, is just the interoperability between companies like the two of yours. Of if you've got some kind of equipment or hardware, software product but the person has a Deere tractor, then they can't use it. And so, I mean, of course you have your own IP, and I'm not saying that it should be completely open source of every technology. It shouldn't be that way. But how do you both think about that as far as really, if you want to help the farmers and someone is using a different color tractor, is there some way that people can work together with the technology stack?
So Kubota adopts an open innovation platform, and honestly, it goes beyond the different color of tractor. I mean, one of the reasons we're here at CES is looking for other technology partners to come in and help us. Technology is advancing really quickly. The way that you develop artificial intelligence models, the sensing platforms, and so we're really focused on solving that customer problem. And I want to accelerate the technology wherever we can. The problems are big enough that I don't think one single company can really solve the problem by themselves. And so it's how do we partner with other companies, looking at pest disease models, looking at different sensing data and data sets. So we're here honestly having conversations, looking for partners to come and help solve the problem. So I don't see it as the different colors of a vehicle. I even don't see it as just specific to ag. I think there's a lot of technology and a lot of support we can get even outside of ag and applying it to agricultural problems. And so some of it's just having conversations with other tech partners and having them realize what kind of problem we're trying to solve and then figure out what that partnership looks like. So for Kubota, it's really about open innovation, and the way that we've structured our systems allows for that interaction.
I think we 100% like believe in accelerating the technology and collaborating with research partners and other vendors. Like if you'll go to the Deere booth, you would see that we have highlighted our partnership with NVIDIA. Like all the four autonomous machines that we are showing, they all use NVIDIA Jetson Orin chip in it. And we 100%, we also believe that there is a lot to learn in agriculture from other sectors like manufacturing, tech, and vice versa. Like in Deere, we have a really good track record of providing 30 years of precision guidance technology that's working really well for our customers so far. And yeah, and what we are doing here is, so we're providing products that would integrate, seamlessly integrate for our customers in their ecosystem and in the Deere ecosystem, and such that the customers would be able to drive maximum return on investment and maximum value in their operation with these technologies and solutions that we are providing.
Scott, what are some of the other big grower pain points that you think could be solved by autonomy and robotics that aren't being solved today that people should be looking at?
Well, let me build on this conversation here with Brett and Groove, because I would say I really like what they're mentioning on this open platform and so forth. And tying into your question, Bonnie, I think that the key that I hear over and over again on the farms is reliability. And that's essential. So in these berry farms, you're harvesting every other day. And it doesn't matter if it's a weekday or weekend or holiday or whatever, just the plants just keep going and going and going. And this goes on for months. And so these crews are getting in there every other day. On the non-harvest days, they're tending to the fields and the crops and improving the overall plant health. And so I think the key is reliability of whatever the technology is that they're utilizing. And when they feel confident, it's like, hey, this thing's going to be reliable, then I think adoption comes along quite well. Okay, now beyond just the sort of getting in the game and the usage and getting with it, what we see in addition to the labor shortage are the effects of climate change and how that is knocking around, all crops, really. We just see it through the lens of berries, but all crops. And we don't feel that collectively we're keeping up with the deleterious effects of climate change. And so how does that look? Well, we have greater heat extremes. It's crazy the pictures that I get. People like, hey, Scott, I can't believe how much rain we got. We've never seen this before, or whatever. So the effects are more and more extreme, and I think that's an area that just generally robotics or elsewise I don't think we're keeping up as an industry, and so the mandate really is we've got to go even faster. To keep going. So in our case, what we're doing is we have 20 different breeding programs for these berries, and it's all natural breeding techniques. So we get a mother and a father, cross it, there's the offspring. But we're constantly accelerating the prioritization of traits that give these plants greater resilience to the climate change. So that's what we're trying to do. That's our part. It's like, hey, let's have these plants be as strong and healthy as they possibly can be. Then we want to partner with the automation companies to say, okay, now can you help us buffet the effects of these climate events? While at the same time we know that labor's not going to get any better. So it's kind of this multidimensional challenge. And we really think all parties, industry, everybody's going to have to really pull together to not only keep up, but try to get out in front of this effect.
If I could just add to that, I completely agree with Scott. When we talk to the farmers, extreme variability in weather, it's a huge challenge. Imagine, I'm trained as an engineer, I depend a lot on a laptop. Similarly, farmers, they depend a lot on weather. And the most important thing that's going to determine your yield is actually not in your hands, and it's variable. So that is a huge challenge, for our customers. Completely agree. And I think the solution that we see is precision technologies. Autonomy plays a big role in it, but giving these tools, these solutions to the farmers so that they have the capability to be able to take care of the plant by plant level. And then they have this, these capabilities so that they can work, with the extreme variability in weather that they face in their operations.
But it's really, it's taking in the weather data and taking in and modeling it, helping them provide, get some insights on what they need to pay attention to. And as Scott said, we're not keeping up. We do need to move faster. But it's through that entire work loop. The robotics are important, but we also have to do the assessment on a plant-by-plant level and know how and when to deploy the robots, and what's the configuration, what are they going to do? And one of the first steps is you've got to assess it, and then with AI, bring in the weather data, the crop data, provide the recommendation, and then the action. And then the third part, this goes back to the question that you kind of started with, is kind of where are we in terms of deploying these? And I still stand in terms of certain tasks, we're there. But Scott answered it through an adoption standpoint, and there's a big variability there, and it has to do with trust. And so there's a reliability aspect, but we also have to earn the trust because the farmers are putting everything on the line, and they've got that season to go and earn the money from that crop, and you can't have the robot messing up that crop. They've got that harvest, and so how do we build that trust? And that's working with the customers in that innovation loop and making sure that we're building what they need, and they are gaining the trust of the robots that it's actually doing what it needs to be doing.
What I loved, what I heard in your answer and what all of you are kind of saying is, I don't know if I'm just listening different or we're actually thinking more holistically about farming, but you're not just thinking about, I'm going to make a robot that does this, or I'm going to develop a tech stack that does this. You're really thinking about how it's a system, that all has to work together. And as we're able to get more and more data, it informs all these things. And so I think that's a very, very different way of thinking than we have been. Scott, you were gonna?
I want to add one other ingredient too, Bonnie. This kind of gets to the age factor that Groove mentioned. This is cool stuff. And so these solutions are making farming cool. And it's bringing in a new generation to farming. It hasn't solved the age challenge yet, but it's helping open the door to that. I think it's also a vital ingredient to this kind of integrated farm. So, for example, you have somebody that's it could be a son or a daughter of the husband and wife that own the farm. That'd be a common example. Or somebody has just come out of a university program, and they've been geared up towards a more technology-centric view towards farming. That's a critical ingredient, I think, to bring on the farm as well, because they're really thinking farm of the future, but they've got to live in the farm of today, and they got to help bridge this over, right? So we're starting to see that as a key ingredient to each one of these farms, to say, who is your person that's really going to help spearhead and bring this technology onto the farm and get that farm ready for success?
So that will lead into the last question as we're running out on time. And Scott, I'll let you continue on that so how do you see this going in, say, the next 5 years, and especially kind of looking at the automation and robotics piece of it? How is it going to expand? And in 5 years, what's the percentage going to be on your farms of adoption?
Just quickly, we think that it's the underlying economics will show the velocity. And we're seeing that already. So we expect, again, California, England, Australia, these places, they're going to have full adoption first, and then that gives us these model farms that we think then it's our job to really help profile. Well, how did that happen? And what were the failures that you learned from? But what were the keys to success? And then we'll keep sharing that and see how this rolls across each continent.
So I think the future is super exciting. At Deere, we have said that our vision is of 2030 autonomous farm for soy and corn production. That means all the main jobs on a farm: tillage, planting, spraying, grain cart, combine. We want to have the tools available for our customers to be able to use that autonomously. And completely also want to highlight is that all of this really, the kind of the key for all this is building with the customer. In Deere's tech stack, we've been building with the customer. This autonomous solution that you see, it's out there in the market for last many years. We have been not just like taking their input, see how we solve their problems, but also testing with them day in and day out. And I think that's the key, and we look forward to realizing that 2030 autonomous farm for soy and corn.
Yeah, I'm going to echo. I mean, right now is an exciting time to be in ag tech, and you mentioned getting talent in, and so I hope that the people out there, if you're interested in robotics, you come in, because now's the time to get in. We're doing some amazing things, and we're hiring, by the way. So anyway. But in terms of the next 5 years, you're really going to start to see that integration of assessment and analyze. I mean, everyone's talking about AI, and that AI leads into commanding the robot correctly. And so you're going to see the workflows really start to integrate the robotics in the next 5 years. And then once we have the model farms, as Scott said, the farmers talk amongst themselves. And as much marketing as we can do, they trust each other a lot more. So once you show productive results, on a couple of seasons, you're going to start to see more and more rapid adoption of this technology. So I'm really excited about the future in the next 5 years.
Great. Well, thank you. That was a really great conversation and enlightening. And thank our panelists.